Hey everyone, welcome back. So far, we talked about the LP modeling and the graphical method as a solution approach. And although the graphical method is good to help us in the conceptual understandings, it's impossible for solving the LP with 4 or more decision variables, right? So in this case, the other solution approaches are necessary. And even though we are not gonna go through the details of the simplex method, I've just got to tell you that George Donchik's the simplex method or the simplex algorithm is the famous and popular and also very efficient solution algorithm for LP. And that is the standard method employed on many optimization solver, including Lindo and Lingo, that we are going to talk about today. And just to let you know, I do have previously recorded video lectures about this simplex algorithm. So if you want, I can provide you the web link so you can access and actually watch them if you want. So please let me know, okay? So today we are going to talk about Lindo and Lingo. That's the, like I said, one very popular optimization solver, and also it's really easy to use. So first, let me share my screen. Okay, here's my slides. Okay. Okay. Okay, so before we talk about Lindo and Lingo, let's consider a simple example. Just let me turn off my video camera, just in case. Okay, so in this example, a firm manufactures chicken feed by mixing 3 different ingredients. Okay? And each ingredient contains 4 different key nutrients. They are protein, fat, vitamins A and B. Okay? And the amount of each nutrient contained in 1 kilogram of the 3 basic ingredients summarized in this table. So if you look at the bottom row, the cost per kilograms of each ingredients are 55 cents, 42 cents, and 38 cents respectively, right? And each kilogram of the feed must contain at least 35 grams of protein and a minimum of 8 grams and also maximum of 10 grams of fat and at least 180 units of vitamins A and 9 units of vitamin B, right? So you're required to formulate an LP model for finding the feed mix that has the minimum cost per each kilograms, okay? Okay, so as a user, we need to define the decision variable, right? So how do you define the decision variable in this case? Because the primary decision for this problem is to know how much of each ingredient should be included in the mixture, right? So we define X variable like this. So X1 describes the number of kilograms of ingredient number 1 included in the mixture, and X2 is the ingredient number 2, X3 is the ingredient number 3 included in the mixture. Okay, so using this set of decision variables, we can formulate the LP model, right? So the objective function, in this case is to minimize the total cost, right? So it can be expressed with a mathematical form just like that. Of course, we are going to use these 3 constant values as the objective coefficient, in this case, C sub I, right? This is going to be C sub 1, C sub 2, and C sub 3, okay? So okay, so that's going to be actually same as minimize 0.55 x1 plus 0.42 x2 plus 0.38 x3, right? So that's going to be our objective function. Now we need to consider the constraints, right? And the first constraint is about the protein requirement, right? So each kilogram of the feed must contain at least 35 grams of protein. So using the first row of this table, we can construct the protein constraint. That's going to be 25x1 plus 45x2 plus 32x3 must be at least 35, right? That's quite straightforward, right? And next constraint is about the fat requirement, okay? So each kilogram of the feed must contain a minimum of 8 grams and maximum of 10 grams of fat. So it can be expressed with a mathematical form like this. Of course, you can combine these 2 constraints, right? So instead of having the second constraint, for example, or even instead of first constraint, you can put like that, right? So that you're going to have only 1 constraint. But because of the because both LINDO and LINGO does not take this form of constraint, so I'm gonna use the 2 constraint instead of 1 constraint. But both expressions correct. Okay. Okay, and next constraint is about the vitamin A requirement. So each kilogram of the feed must contain at least 180 units of vitamin A. And using the table values, we can construct mathematical form like this. Likewise, vitamin B constraint can be constructed like this. And we do need to consider one more constraint, because in the problem description, it does require that the total weight of the mixture should be 1 kilogram. So the summation of x1, x2, and x3 should be equal to 1. That's why, okay? So we have to include this last constraint. And also we need a sign restriction that is associated with each decision variable, right? So because each ingredient included in mixture cannot be negative, so it's necessary to restrict the decision variables to be non-negative, okay? So combining all together, this is the complete LP formulation for this example problem. Okay, so now let's use LINDO and LINGO to solve these example problems. Okay, so what is that? Okay, let me move this slightly to this side. And then I'm going to show you how to download the LINDO and LINGO software. So if you type in lindo.com in any web browser, okay, then you are gonna get this vendor's website. And in the top menu, click on download, and you're going to download LINDO, okay? And I believe, okay, so if you're using the Apple computer, definitely you're gonna download this and Linux and Windows machine. So in my case, I'm gonna download a Windows 64-bit option. So just click on it. And I'm gonna provide my profile. Okay. Okay, so I'm gonna click on, and here, this is the web link where I can download Lingo software. So I'm gonna download Lingo, the latest version, which is version 20. So it's gonna take like a minute or two. Okay, it's very fast right now. So I'm gonna click on it. And double click the execution file. Okay. And I guess you need an administrative privilege to install this Lingo software in your computer. And I'm gonna, okay, click next and accept the term license agreement. And I'm gonna, okay, install everything here. Okay, so we are almost done. Okay, it's done already. So after you do this, in your desktop, you're gonna see this icon, Lingo. So if you click on this, double click, where's that? Okay, so now you are in the Lingo software. Okay, and of course, you can also download the same software, Lingo, from our Canvas system. In the course syllabus, I provide the same link, web link. And you can also download the user's manual from here, okay? And I also provide the same web link in our course syllabus, in our class Canvas website. So please do so, okay? Okay, so let's get back to our Lingo and Lindo. So now we are going to use Lindo. So actually, without downloading the Lindo software separately, you should be able to use Lindo within this Lingo solver. So in order to do that, what you need is click on server, and there is an option. And there are several menus, right? And be sure to select interface. And then within this file format box, you're gonna select the last option, LTX, parenthesis, Lindo, okay? And then press apply, okay. And then after that, open the new window, okay? Now you can see Lindo model, right? On the top of this, this window. So previously it was Lingo, and right now we should be able to work on Lindo input within this window, okay? So I'm gonna put this on the back because we are going to use Lingo right after Lindo, okay? So here in Lindo model window, we're gonna input our math formula, okay? So first of all, I just say the Lindo model consists of 3 different parts. They are objective function, constraints, and also ending mark, okay? So for the first requirement for Lindo, an objective, you have 2 different choices, either max or min, okay? So max stands for maximize, or min stands for minimize, okay? So actually you can also use maximize. Okay, increase the font size a little bit. So, okay, this is better, right? So in our case, we are going to minimize the total cost. So we have to type either min or minimize, okay? It really doesn't matter. And both Lindo and Lingo are not case sensitive. So minimize or even minimize the identical expression, okay? Or min, okay? All of these 4 expressions are identical in Lindo, okay? So I'm gonna use min, okay? And the first word in a Lindo model should be either min, minimize, max, or maximize, okay? And the formula you enter right after the min or max is called the objective function. So in our case, I'm gonna just type in our objective function. X1 plus 0.42 X2 plus 0.38 X3, right? So, and also let you know, Lindo does not need asterisk as the symbol of multiplication. So if you actually use asterisk as the multiplication symbol in Lindo, then actually Lindo will give you the error message. So do not use it, okay? So this is going to be our objective function, right? And on the next line of the objective function, we'll need to enter the words subject to or just st. Either is fine, okay? And then on the next line of your model, you're gonna enter each constraint one by one, okay? So let's do that. Our first constraint is 25x1 plus 45x2 plus 32x3, okay? So it really doesn't matter if you put space between the objective coefficient and the decision variable, okay? And also you can use capital X instead of small case x, okay? Because it's the same expression in Lindo and also in Lingo, okay? And it's going to be greater than equal to 35, right? So that's our protein constraint. And fat constraint is going to be 11x1 plus 10x2 plus 7x3 has to be greater than equal to 8. And also 11, let me just copy the left-hand side. Then paste. This is going to be less than equal to 10, right? And let's move on to the vitamins A and B constraints. So 235 x1 plus 160 x2 plus 190 x3 greater than equal to 180. And then 12 x1 plus 6 x2 plus 10 x3 greater than equal to 9, okay? And x1 plus x2 plus x3 greater than equal to 1. No, it's exactly equal to 1, right? The last constraint. Okay. And just to let you know, the Lindo assumes that all of the decision variables are constrained to be non-negative and also continuous. So the non-negativity restrictions are necessary for both Lindo and Lingo input. Okay, so which means that we are not going to type in the non-negativity restriction, which is x1 greater than equal to 0, x2 greater than equal to 0, x3 greater than equal to 0. Okay, we don't need this. Okay, so actually you can still include it, but there is no point to include that. Okay, because it's not necessary, because that's the default option for Lindo and Lingo. Okay, and then on the line after that, we designate the end of the constraints by adding the ending mark, END. Okay, so END, either is fine. And what else? And before we move on, okay, and just to let you know that in Lindo, keep in mind that all of the decision variables, the constraint set, should be located in the left-hand side. So as you can see here, all of the decision variables, x1 and x2 and x3s are placed in the left-hand side of the first constraint. The same for second, third, fourth, and fifth, and sixth. All of the constraint sets, if you look at that, all of the decision variables are located in the left-hand side of each constraint, which means all of the constant values has to be located in the right-hand side, right-hand side of each constraint set, okay? And what else? I can also tell you that, for example, an expression can be broken up into as many lines as you want, actually. So for the objective function, this is going to be doable, okay? So for example, you can include some comments, for example, for the easier readability. So that's going to be the cost for ingredient one, for example, like that. And also here, right after the exclamation mark, you can put the comments. So is that the protein requirement? Likewise, here, you're gonna input the comments. That is the fat requirement. And this is also fat requirement, right? Something like that. And what else? I think that's about it. So if I miss something, then I'm going to come back and then provide you. But as of now, I believe this is the all for Lindo. So once you enter the math model into the Lindo model window, then you are going to press this button, okay? Solve button. Or in the solver menu, if you press solve, okay, or control U, then Lindo will solve this linear program and then give you the solution instantaneously, because this model is very small size, right? So let me do that. See, we already got the optimal solution. So according to the Lindo output. Here, this is the objective function value, right? So it does tell you that the minimum mixture cost is going to be $0.398 per kilogram. And that does consist of the 0.045 kilogram of ingredient number 1 and 0.27 kilogram of ingredient number 2 and 0.68 kilogram of ingredient number 3. Okay, that's how you can provide your answer from the LINDO output. Okay. Okay. Okay, now let's move on to Lingo. So just to let you know, if you want to use Lingo, then again, you need to select solver from the top menu and choose options. Again, in the interface menu, within this file format box, be sure to choose LG4, parenthesis extended, for using Lingo, I'm sorry. And then don't forget to apply, okay, and open the new window, okay. Now you can see that the top of this new window, it does say Lingo model, okay. So this tells you that now you can use Lingo within this new window, okay. Okay, so the Lingo model starts with the word model colon, and also end with ending mark, like that, okay. And then we are going to input the linear program model between these two, okay, model colon and ending mark, okay. And unlike Lingo does not recognize the word minimize or maximize. So you have only two options. That is max or min, okay? For the objective function. So in our case, we are going to minimize the total cost. So I'm going to write down min, okay? Again, you can use min or even min. Okay, it really doesn't matter, okay? For both Lingo are not case sensitive, okay? And right after the words min or max, the equal sign is required for Lingo, okay? So our objective function 0.55 x1 plus 0.42 x2 plus 0.38 x3, okay? That's gonna be our objective function, but be careful. Unlike Lingo does need the asterisk as the symbol of multiplication, okay? So you do need to provide asterisk, okay, where it is needed, which implies lingo also take slash as the symbol of division, like lindo, okay? Lindo does not recognize the slash as the division symbol, but lingo does, okay? And lingo also recognize parentheses, okay? But lindo does not. So for example, here I can use parentheses, and here /2 and multiply by 2 and parentheses, and that's identical expression, okay? And on the next line of the objective function, we don't need the words subject to nor the letters st. So you are not going to write down subject to nor st, okay? We don't need it. If you do that, then Lingo will give you an error message. So there is slightly differences in the syntax between the Lindo and Lingo, okay? And each mathematical expression in Lingo will be typed in here. So 25x1, sorry, don't forget the asterisk as the multiplication symbol, x1 plus 45 times x2 plus 32 times x3 is greater than or equal to 35, okay? And another very important thing to remember while using Lingo is that each mathematical expression in Lingo is terminated with a semicolon. So you have to put the semicolon right after each constraint set, okay? And I forgot this earlier. Even after the objective function, you have to put the semicolon, okay? So Lingo cannot solve the model without the semicolon, okay? And let me just copy from Lindo and then paste it here. And then I'm gonna modify that, okay? So we do need asterisk, right? As the multiplication symbol. Right? And also you're going to put semicolon at the end of each constraint, okay? Also, just like Lindo, the expression, any expression can be broken up into as many lines as you want. But in Lingo, don't forget, the expression must be terminated with a semicolon like that, okay? So we could have used these two different lines, okay, rather than just one line to contain the objective function, okay. And likewise, LINDO, we can also include some comments to improve the readability of our model. And the comments always begin with an exclamation mark here. And also comments end with a semicolon, okay? So this is the protein constraint requirement. And then you're gonna put the semicolon, okay? So keep in mind that in Lingo, all the text between the exclamation mark and the semicolon is ignored by Lingo, okay? So even here, if you want to put the comments, so that's gonna be the cost of ingredient 1, you're gonna put semicolon, okay? And also, let me move this like this to show you that the comments can occupy more than one line, okay? You can share lines with other Lingo expressions, okay? And what else? Oh, and what I'm doing this, you already recognize that. The Lingos has another very useful feature that is called syntax aware. So in other words, when it encounters Lingo keywords, it displays them in blue color like that. Min or max, model, ending mark, okay? And those are all in blue color, right? Because that's the Lingo function, which means you cannot use these words as your decision variable, okay? And you can see this, all of the comments are displayed in green color, okay? So this is really good because, for example, if you forgot something like that, for example, if you forgot the semicolon right after the comments, then Lingo shows all of this or the other objective function terms as green color because Lingo take all of this as the comments because you forgot to type the semicolon right after each comment, okay? And you can see that all of the remaining text is displayed in black color, okay? So, of course, you're gonna find this feature very useful, especially while you are tracking down the syntax errors in your models, okay? So after that, if you press this button, then you're gonna get the optimal solution right away, okay? So you have the same optimal solution as before, okay? And just one more thing. Before we end the lecture, I gotta tell you that both Lindo and Lingo assume that all of the variables, decision variables, all of the decision variables are constraint to be non-negative and continuous, right? So I mentioned that non-negativity restrictions are necessary for both LINDO and LINGO, the LINDO and LINGO inputs, right? However, when you deal with the real-world modeling projects, you will be faced with, for example, yes/no types of decisions. So, for example, some examples that include open the production facilities or close the facilities, or other cases like if you want to produce certain final product, or if you don't want to produce the final product kind of decision, right? So in that case, binary integer or 0 and integer variables are the standard method used for modeling these yes/no types of decisions, right? So for LINDO, we can include these binary integer restrictions using the INT, using the INT or INTE, okay? It doesn't matter, after the ending mark. So for example, you can mark INTE x1, INTE x2, or INT x3, something like that, okay? That does work. Or alternatively, you can put INTE3. So in this case, LINDO will take the first 3 decision variables to be the binary integer. But be careful, if you want the x2 and x3 variables to be the binary integer, but x1 to be the continuous variable, then you cannot use this expression. You cannot even use INTE2. In such case, LINDO will take the first 2 decision variable. So in our case, the x1 and x2 variables to be the binary integer, okay? So be careful. So for example, here, you can put x1 like that, okay? To be restricted, x1 variable to be the binary integer variable. And for the LINGO, we use a different keyword. Actually, in this case, we are going to use bin. And slightly different syntax, okay? So for LINGO, we are going to use at inside parentheses, we're going to use like this. Oh, sorry, not here. Inside parentheses, you're going to specify the variable name. So this is going to be the identical expression. Okay, it's LINDO and LINGO. This one should be identical in LINGO. Okay, but be careful. For LINGO, this variable restriction has to be placed before the ending mark. Okay, but in LINDO, additional variable restriction has to be specified after the ending mark. Those are the differences between LINDO and LINGO. Okay. Okay, and what else? Oh, there is one more thing. You might also want a decision variable restricted to be purely integer values, right? For example, if you want to assign people to a certain job, then you cannot assign 1.25 people, 3.785 people to a certain job, right? So the decision variable should be the positive integer values in this case, right? So for this case, the general integer variables are the standard method. And for Lindo, you can include this general integer restriction using GIN after the ending mark. So for example, you can put x2. That means you want the x2 variable to be the general integer, while the x1 variable to be the 0, 1 binary integer, okay? The same expression, same requirement for Lingo will be at GIN, okay? So for the general integer restriction, both Lindo and Lingo use the same keyword GIN, okay? And inside the parentheses, you're gonna specify which variable should be the general integer, okay? Like that. So if you run it, then you're gonna see that feasible solution. Oh, I see. Okay, so in this case, we have an infeasible solution. So let's increase the right-hand side value, for example, okay? And let's disable this constraint. So I'm gonna put the asterisk symbol and let's see if we got the optimal solution. Okay, now we got the optimal solution. Let's switch. This is 1 and 2, for example. See if you get the desired objective function value and the optimal solution. Yeah, because I just want to show you how these variable restrictions, additional variable restrictions impact on our optimal solution. So can you see this? So here, if you look at x1 variable, it has the general integer value, right? Here. Because of this additional variable restriction. And x2 value has binary integer value. It's gotta be x1, it's gotta be equal to 0 or 1, right? Based on this additional variable restriction. But x3 value can be the real value because we didn't put the integer variable restriction, right, in here. Okay. Okay, so I think this is all for today. So next time, I'm gonna give you more example problems for the linear programming modeling and also for both Lindo and Lingo, okay? Okay. Okay. Okay, thank you very much. Okay, I will see you next time.